Hi everyone, welcome to this video lesson. In this lesson, you will learn how to solve systems of equations by graphing. So a system has two or more equations, and to solve means to find the point of intersection. So it could be two lines, it could be a line and a parabola, it could be, I don't know, it could be many different graphs, okay? But just keep in mind it's got to have either two or more equations, and you want to see where those two graphs intersect. So we're gonna do solve systems of graphing today. So I'm gonna go over the next few examples, and the first thing we need to do is to graph the following systems of equations. We got to say the solution and classify the system as independent, dependent, or inconsistent. And I'll explain what each one of these terms means. Okay. So for example, to be able to solve the system, we need to write each equation in this form, which is slope-intercept form, so that we can graph the equation. So in this case, I'm going to take this one to the side, okay? And what I need to do is I need to move the x to this side, which means I'm going to, let me just copy it, and then I think this will make sense to you. So we have x plus y equals 3. Subtract x from both sides. So then this gives you y equals negative x plus 3. So this equation, this one here becomes that equation. So I'm going to take this one here and do x minus y equals positive 1. I'm going to move the x to this side, which means I'm going to subtract the x. So then I have negative y equals negative x plus 1. But I want the y to be positive because I don't want, so I can have that in this form. Notice the y is positive, so let's divide by negative 1, each one of the terms. So then y equals negative x divided by negative 1 becomes positive x. 1 divided by negative 1 becomes minus 1. So what I'm going to do is I'm going to graph this line with blue. So it's going to cross the y axis at 0, 3. So this is 1, 2, 3. And then notice the slope is negative. So it's a rise of 1, run of 1. Since it's negative, if I go down, then I go right. And I get one more point. I can keep going down and get as many points as I want. Okay, so then that should be enough. Then I'm going to use my ID or a straight edge to connect the points. So let's see, I'm going to connect those 4 points so I can sketch the graph. And there is this line. So notice for this, you will need to use a straight edge. Do not try to do it by hand because you won't be able to see clearly the intersection of the two lines. So for this one crosses the y-axis at 0, negative 1. So that's this point, and from there, rise of 1, run of 1. So up 1, over 1, up 1, over 1, and this is where we see the lines intersect. Okay, so then I'm going to connect the points for this graph. And as you can see, the intersection happens at this point. So the question is, what is the x and the y coordinate at that point? So x is positive 2 and y is 1. So 2 comma 1. So this is the solution to the system of equations because that's where the two lines intersect. So this system is independent. Okay, so whenever you have an intersection, only one intersection, then that's an independent system. Why? And I'll just explain. Because there's only one crossing. Okay, so there's crosses, or they cross once. The lines cross only one time, and that's the reason why. Okay, so with that said, let me go over the second example. So for the second example, again, the first equation, I'm going to copy it here. So this is y minus 5 equals 3x. All I need to do is move the 5 to the other side, which means I'm going to add 5 to both sides of the equation. So then y equals 3x plus 5. And I'm going to graph this line right away. Okay, so notice the y-intercept is 0, 5. So then this is 1, 2, 3, 4, and 5. So this is where the line crosses the y-axis. Has a rise of 3 and run of 1. So I'm going to go down because I can't go up. So down 1, 2, 3, then over to the left 1. Down 1, 2, 3, and over to the left 1. Then I'm going to connect the points so I can sketch the line. So there is the line of the first equation. So to make it more clear, I'm going to do this one with red. So I'm going to take this here. So I have 2y is equal to 6x plus 10. Then I'm going to divide by 2 because that's all I have to do so I can get the y by itself. Okay, so then we have y equals 6 divided by 2 is 3, so 3x, and 10 divided by 2 is 5. So then if I sketch this line, it's going to cross the y-axis at 0, 5, so that means they have this point in common. But from there, I'm going to go down 1, 2, 3 over 1, and then 1, 2, 3 over 1. As you can see, we get the same 3 points. I mean, I'm still going to connect them, but I hope you can see that this line or these equations are the same. Okay, so they are the same equation for both. So what does that mean? So in this case, as you can see, this point is on the line, this point is on the line, and if you plot any points on the line, they have all those points in common. So the question is, how many solutions does the system have? And the answer is, since lines are infinite objects, then we have infinite number of solutions. So we have an infinite number of solutions for this system because it's the same equation. Okay, so infinite solutions, and then I'll explain what this means in a moment. So since we have the same line, okay, so we have the same line, then this means it's dependent. So if it's only one intersection, then they only cross one, so that means independent. If it's the same line, then this is a dependent system. So if the question is asking, okay, what is this system dependent, independent, or inconsistent, then you would say dependent. And let me spell that correctly. Dependent. All right. Let's move on to the last example for this lesson. So for the last example, I'm going to take this to the side here. So we have negative y is equal to x. We don't want negative y, so let's divide by negative 1 to make that y positive. So then y equals negative x. Okay, which means this line passes through the origin because the y-intercept is 0, 0. So we plot that point first, and then notice the slope is negative. So if I go down 1, then I have to go right 1. Down 1, right 1, and 3 points should be enough. Then I'm going to connect those 3 points to sketch the line. So there is the graph of the first equation. Okay, now let's do the second one. So I have this one here. This is x plus y is equal to 4. I'm going to subtract the x from both sides of the equation. So then we have y equals negative x plus 4. So the y-intercept for this one is 0, 4. So this is 1, 2, 3, 4. Plot a point there. Then the slope is negative 1 over 1. So if I go down 1 over 1, down 1 over 1, and those 3 points should be enough. Okay. And I hope you're seeing right away, your brain should be telling you, hey, there's something interesting happening here between these two lines. And that is that they will not intersect. The question is why. Notice this is negative 1 and this is negative 1, so they have the same slope. So if lines have the same slope, then the lines are parallel, which means they will never intersect. So in this case, as far as solution is concerned, we say that this system has no solution. Okay, so we call this system inconsistent. Consistency means there are solutions, at least one. This one is inconsistent because there are no intersections. So if the question is asking you, is this an inconsistent or consistent system, then you would say inconsistent because there are no intersections. Okay. And I'll just add something else here. So no solutions, the system is inconsistent, and then which implies that parallel lines don't intersect, okay, which means they don't cross each other. And with that said, this is all for this lesson. Thank you for watching. Bye-bye.